So, how does someone actually learn to code these days? I mean, how do you go from zero to building your first program? Well, it's not just about cracking open a textbook anymore. Today, it's this really cool blend of big, formal ideas and super friendly, practical guidance you can find online. Let's dive into how those two worlds come together to teach you how to code.
On one hand, you've got the traditional starting point. You see a quote like this from a national textbook, and it sounds pretty serious, right? Almost a little intimidating. But it's making a super important point. Understanding computers isn't some niche skill for tech wizards anymore. It's becoming fundamental for, well, pretty much everyone.
And then you have this. Hi, welcome. That's the opening line from a massively popular YouTube tutorial. The whole vibe is completely different, isn't it? It's warm, it's welcoming, and it immediately makes you feel like, okay, I can do this. These two greetings right here, they perfectly capture the two sides of learning to code today.
Okay, so where does the journey actually begin? Well, funny enough, it's not with writing code. The very first step, the big idea, is all about shifting your mindset. It's less about the specific commands you're typing and way more about how you approach problems in the first place.
See, this is the real prize. Learning a language like Python, that's just the tool you use to get there. The ultimate goal is to build this skill called computational thinking. Just think of it like learning a recipe for solving any problem. You take a big, messy challenge, you break it down into tiny, manageable pieces, and then you lay out a step-by-step plan to solve it. And that's a skill you can use absolutely anywhere in life. All right, so we've got this big, abstract idea of thinking like a computer. But how do we actually turn that into, writing some code? This is where those online tutorials are just fantastic. They totally take the fear out of getting started and make it feel not only possible, but actually kind of fun. Take this little gem, for example. The instructor on YouTube drops this fun fact. All of a sudden, Python isn't this scary, technical monster. It was named after a comedy show. Little details like this just make the whole thing feel so much more human and way less intimidating. And here is that practical approach in action. Setting up your computer for coding can sound really complicated, but look how it's broken down here. 3 simple steps. 1. Get the language. 2. Get a place to write your code. 3. Add a couple of helpful tools. Boom, you're done. What could have been a frustrating roadblock just became your first easy win, and that feels great. Okay, so your computer is all set up and ready to go. Now what? What are the very first things you actually learn? And what's really interesting is that this is where the formal textbook and the friendly online tutorial completely agree. This is the essential toolkit for every single programmer. Everything, and I mean everything, starts with variables. The absolute best way to think about a variable is just like a labeled box. You give the box a name, like user_name or score, and then you put a piece of information inside it. That's it. It's how a program remembers and keeps track of stuff. Now, of course, you can't just name these boxes whatever you feel like. There are a few simple rules you gotta follow. But these rules aren't just random. They're there to help keep your code organized and easy to read, and to make sure you and the computer are always on the same page. So you've got your labeled box, your variable. But the computer needs to know one more thing. It needs to know what kind of information you're putting inside. Is it a word? Is it a number? Is it just a simple true or false? This classification is what we call a data type. And honestly, when you're just starting out, almost everything you work with will fall into one of these 4 basic categories. You've got text, which we call strings. You've got whole numbers, which are integers. You have numbers with decimals, we call those floats. And you have simple true or false values, known as booleans. This is your core set of building blocks. Now this, right here, is one of the biggest reasons why Python is so amazing for beginners. In a lot of other languages, you have to tell the computer everything up front. You'd have to say, hey, I'm making a box for a whole number, and I'm naming it age. But with Python, you just say age equals 20. And Python is smart enough to just look at the 20 and go, yep, that's a whole number. Got it. It's called type inference, and it makes your code so much cleaner and more intuitive to write. So, let's take a step back. We've got our variables, our little boxes, and we know about our data types, the kind of stuff we put in them. We're assembling our toolkit. But it is so crucial to remember that these tools, they aren't the final product. The real magic happens with what you build with them. Which brings us right back to the most important question of all. Why are we even doing this? Why are we bothering with labeled boxes and data types and all this syntax? What is the actual point?
That's the point. Every single variable, every line of code, every concept you learn, it is all in service of one thing: solving problems.
The textbook lays it out for us like a professional blueprint. First, you really understand the problem. Then you create a step-by-step plan to solve it. In the coding world, we call that an algorithm. Then you write the code, you test it like crazy to make sure it works, and finally, you maintain it over time. It's a structured, reliable way to tackle any challenge.
And this is where that YouTube tutorial just nails it. It takes that formal process and makes it real with simple, everyday examples. How do you find the average of 3 numbers? How do you figure out how much interest you'll earn at a bank? These aren't just random coding exercises. They are real, tangible problems, and your code is the key to solving them.
So, we've kind of come full circle. We've seen the two sides of the coin, the big, foundational theory and the friendly, hands-on tutorials. And it really leaves us with this one big question to think about. Is the real goal to just get good at a programming language? Or is it actually about learning a powerful new way of thinking that you can use to solve just about any problem that comes your way?